video, we're going to look at how we add and subtract algebraic fractions. Okay, quick recap of how we add and subtract regular fractions. First thing what you want to do is find a common denominator. So that's normally done by just multiplying the two denominators. So 5 times 3 is 15. So this 5, 1/5 has become 15ths. So the bottom line got multiplied by 3. So the top line also gets multiplied by 3. So 1 times 3 gives you 3. Same idea. This 3 here got multiplied by 5 to get up to 15. So this 2 gets multiplied by 5 to give you 10. And in a numerical example like this, obviously you can tidy up a wee bit. So it's 13 over 15, and that's us done. Example B, it's an algebraic fraction one. Common denominator then is going to be xy. And this x got multiplied by y to become xy. So its top line also gets multiplied by y. This y got multiplied by x to become xy, so its top line gets multiplied by x to become 3x, and that's as good as you can go. This example, we have a simplifying example, and common denominator is going to be 6. This 2 needed to be multiplied by 3 to get 6, so its top line gets multiplied by 3. Likewise, this 3 gets multiplied by 2, so its top line gets multiplied by 2, and just take care. This is where people will make mistakes when you're multiplying out the minus 2 times the x and the minus 2 times the minus 2. Just take care on that, please. So we're going to multiply out still all over 6. You're going to have 3x plus 15 minus 2x plus 4. And then we'll tidy up. We're going to have x plus 19 all over 6. And that is as good as we can go. Next example, a wee bit trickier. We have to take a common denominator. Common denominator is a bit trickier. Just it's going to be x plus 1 upon 3x plus 1. And the top line over here, the x plus 4, needs to get multiplied by 3x plus 1. It's getting a wee bit messy here. Then the x plus 3 gets multiplied by x plus 1. So a good bit of multiplying out and tidying up to do. What I'm going to do is this pair of brackets here, I'm going to make it into one big bracket. Likewise, this, I'm going to make it into one big bracket. Just, it's not going to really make a difference in this question, but had this been a negative, it's very easy to make mistakes. So it's good practice to do what I'm about to do. So bottom line, I'm going to leave it as x plus 1 times 3x plus 1. And I said, first pair of brackets becomes one big long bracket. Second pair of brackets becomes one long bracket. Okay. You've got x times 3x, which is 3x squared, and then I'm going to skip a step here. I have x times 1, which is x, and I have 4 times 3x, which is 12x. 12x plus 1x will be 13x, and then I've got my 4 times my 1, which is just plus 4. Over in the other one, I've got x times x, I've got x squared, I've got x times 1, which is 1x, I've got 3 times x, which is 3x, so it'll become 3x plus 1x is 4x, and 3 times 1 is 3. And then you can tidy up. I've got x plus 1, 3x plus 1, and top line becomes 4x squared plus 17x plus 7. And that is it. Okay, next example. And they've given us a very big clue here to factorize. We want to group these together, so we want to factorize everything. So we've got 2 over x squared minus 4 factorizes to be x minus 2, x plus 2, and then minus, and we've got 1 over, and that will factorize with a wee bit of work from your sum and product to be x plus 2, x plus 3. Okay, right. Let's think back to numerical examples. If I had a fifth plus 1 over 25, so 1 over 5 plus 1 over 25. My common denominator, I could multiply those two and have my common denominator as 125, which would work and would be fine. A wee bit trickier, but it would work. Here, we do not really want to do that because what we have here, we have got x plus 2 is common in both. So basically, our common denominator, we just need to have our x plus 2. We also need to have our x minus 1. And we also need to have our x minus 3. So this x plus 2 here, I'll get rid of 1. That's what we need to have as our common denominator, and it'll make life much, much easier because it gets very complicated if you don't recognize that. So it's the lowest common denominator, remember, when you're multiplying or adding or subtracting fractions. So that's really what we want to think about here. So let's write down what our common denominator is going to be. It's going to be x minus 2, x plus 2, and then just x plus 3 again. So our 2 over here, this thing needed to be multiplied by x plus 3, so this top line gets multiplied by x plus 3. Over here, this thing needs to be multiplied by x minus 2, so our 1 needs to be multiplied by x minus 2. So what you've got is 2 upon x plus 3, then it was a minus, so minus, and then it's just going to be x minus 2. And then tidy up, multiply out and tidy up the top line. You're going to have 2x plus 6 and minus x plus 2. Just be careful with that one. And then you have x minus 2, x plus 2 upon x plus 3 in the bottom line. And then again, just tidy up and see what you get. You've got x plus 8, top line. Bottom line is x minus 2, x plus 2, and x plus 3. And that is as good as we can go. Okay, this next page has got 3 fairly strange examples. I don't think we're going to see ones, I guess, to be honest, in an exam, but we might. So we'll just go through them anyway. There's nothing wrong with the questions, just overly tricky maybe, but we'll have a look at them. Okay, it says simplify this expression. So let's just look at this expression. We want to simplify it. Now, what you could do is basically what I'm going to do here is I'm going to multiply the top line by x and the bottom line by x. So it's almost like the reverse of simplifying. In a way, because you would have had, normally you would have, like, say, 28 over 14, and you would have divided the top line by 14 and divided the bottom line by 14 as well to simplify. But now we're actually multiplying it. But when we multiply by x, 1 over x multiplied by x will just give you 1. The minus 2 multiplied by x will give you minus 2x. And then the 3 multiplied by x will give you 3x. The minus 4 over x multiplied by x would just give you minus 4. So it is actually a much simpler expression you have got when you do it that way. And that's as good as you can go in this particular example. Okay, next one. It says simplify. And we've got to simplify this whole thing. So we have got a fraction minus 2 on the top line, and 5 minus an algebraic fraction on the bottom line here, and then divided by x minus 1, x plus 3, right? Let's just get cracking. This is not pretty. Okay, so I'm just going to work over here. I need a good bit of space for this one. So I'm going to sort out my numerator and my denominator, and then that's going to be divided by x minus 1, x plus 3, but I'm sorting this out first, the numerator divided by the denominator. So on my numerator, I am taking a common denominator, which sounds strange. On my denominator, I'm taking a common denominator again as well. So let's sort out the numerator. So here, this bit's already sorted. You already have your x minus 1. So this is minus 2 over 1. So that 1 here needs to get multiplied by x plus 3. So the minus 2 also needs to get multiplied by x plus 3. Same idea in the bottom line. That's 5 over 1. So it needs to be multiplied by x minus 1. So it's 5 times x minus 1 and minus 7. And then that's an absolute mess. So if something's a mess, you tidy it up. So if we tidy that up, what you're going to get is your top line is going to be x minus 2x. Sorry, I'll tidy this up first. I'll put my x plus 3 here. And my bottom line, I had my x minus 1. And then also what I'm going to do is that was a dividing fraction. I'm going to flip it. So it's x plus 3 over x minus 1. Sort out that top line. You're going to have x minus 2x, which is going to be just minus x. And you're going to have minus 1 minus 6, which is going to be minus 7. And the bottom line, you're going to have 5x minus 5 minus 7, which is going to be 5x minus 12. And then we can go from here. So I will go up to here to do this again. So really what we have, top line was minus x minus 7 over x plus 3. It was being divided by, and this is why this is so messy, it was being divided by 5x minus 12 all over x minus 1. And then you had to multiply by x plus 3 over x minus 1. So the first thing we want to do is sort out that dividing. That's minus x minus 7 over x plus 3, then times x minus 1 over 5x minus 12 times x plus 3 over x minus 1. And then let's see what can cancel. Your x plus 3 goes, your x minus 1 goes, and then you're just left with, it's going to be minus x minus 7 all over 5x minus 12. Last example is a prove that. So we're going to work with our left-hand side, and a proof, remember, work with your left-hand side. And my left-hand side is equal to, I'm going to take a common denominator of, on my numerator, so I'm going to take a common denominator of 2x. On my denominator, I'm going to take a common denominator of 6x. So on my numerator, that's going to become 8 plus x squared minus 6x. And on my denominator, it's going to be x squared minus 2x minus 8. So look back at the previous example to get a wee bit of explanation of how that is done. And then if you do that, then that means you're doing, let's just write it out the long way. You have 8 plus x squared minus 6x all over 2x, and then that's multiplying by 6x over x squared minus 2x minus 8. So I've flipped my dividing fraction, if you imagine. Then we'll go up here to finish that off. And what can we do here? We can cancel, do a wee bit of cancelling as well. I'll do that here. 2x goes into itself once, 2x goes into that 3 times. So you're left with really that's 3 upon 8 plus x squared minus 6x. Much smarter if I had written that the other way around. So we'll write that as x squared minus 6x plus 8. And the bottom line then is going to be just x squared minus 2x minus 8. Now, hopefully we can factorize these things and then something else will cancel. And yes, top line cancels to be x minus 2, x minus 4. Bottom line cancels to be x minus 4, x plus 2. And then you can see what cancels here is your x minus 4s go, leaving you with your last line we've got there, which is x minus 2 over x, 3 upon x minus 2 over x plus 2. And that's us done.